I'm Yvonne, staff for Science for the Public, and I welcome you to Contemporary Science Issues and Innovations. Today, we discuss modern industrial style agriculture, how it affects not only food production, but our planet's soil, the environment, and climate change. Our distinguished guest is David Montgomery, professor of Earth and Space Sciences at the University of Washington in Seattle, and he's also a member of the Quaternary Research Center there. Dr. Montgomery's research focus is geomorphology, the study of processes that shape Earth's surface, including processes that affect soils and their related ecosystems. He's an elected fellow of the American Geophysical Union and has received many awards, including a MacArthur Fellowship and a Vega Medal. In addition to his research, Dr. Montgomery has appeared in the PBS Nova documentary, Making North America, and has winning general science books for the public. Today, he'll discuss his book, Growing a Revolution, Bringing Our Soil Back to Life, which describes the massive destruction by common agricultural practices and how a shift to regenerative farming is necessary to restore the damaged soil and the related ecosystems, in addition to producing healthier food. We are honored to welcome David Montgomery, and thank you, sir, for joining us.
Oh, sure. Thank you, Yvonne. It's a pleasure to see you again and to talk with you.
Oh, great. And I'm delighted about this book, as I mentioned before. Dr. Montgomery, it seems as though we're becoming more conscious in the general public, and maybe beyond, today about soil due to the problems of climate change and understanding gradually of the importance of soil. So the first question, I know you've been asked this a few times, what is the difference between dirt and soil?
You know, it's a great question, and I think I can give you a one-word answer.
Yes.
The difference is life. You can think of, dirt. One way to think of dirt, colloquially, however you say that word, we've all referred to soil as dirt, right? Go out and play in the dirt and stuff. But, in a technical sense, the difference is life. If you have a soil is not just the particles of minerals and that are in it, but it's also the remains of organic matter, things that were once alive, and also the living organisms that are in the soil that actually help cycle the nutrients out of those rock particles and get them into plants. Soil is really an ecosystem. It's a living, dynamic ecosystem made of physical components and biological components. And so you can think of soil as dirt plus life, or you can think of dirt as soil minus life. And so if you take a soil, off of a farm field on your shoe into your house, you've turned soil into dirt. And by the same way, if we erode soils off of farmland and we deposit it somewhere downstream where it's not really a benefit and where we've stripped the life out of it, we've turned soil to dirt. So,
right. Well, that is, I must say, I've been through a few books on soil references. This has wonderful information, and I really recommend people have a look at this because it's very readable, in addition to having a great deal of solid information about soil. But as you say there, the whole thing is that the soil is alive. Could you tell us, what do you mean by alive? What's in it that makes things alive?
Yeah, well, I guess, technically the soil itself isn't alive, but the soil is a living system. So it's life plus, it's kind of like, a forest is a living ecosystem. Lots of organisms, but also you could include the topography on it is part of the forest in a way. When you think of it as an ecosystem, the rain that falls on it sort of cycles through that ecosystem. So when you think of a soil as a living system, we're thinking about all those components that together make it a productive ecosystem. So you're talking about, the roots of the plants, the remains of dead plants. You're talking about the bacteria and the fungi in the soil, and right on up to the worms in the soil
Yeah,
are all part of that system. And of course, the rock particles. I'm a geologist by training, which is how I
right.
got into thinking about soils. But that's just part of the foundation for what a soil really is. It's that I like to think of a soil as the boundary, the interface between the dead world of geology and the living world of biology. It's where those two worlds collide, meet, and dare we say, party. It's it's a dynamic living ecosystem that unfortunately, because it's beneath our visual horizon, it's beneath our feet quite literally, and a lot of that life is microscopic that we can't detect with our own senses. We've tended to, be unaware of or overlook or discount the importance of the life part of the soil.
Yeah.
And yet, one of the big lessons of the 20th century, I think, for soil scientists and agronomists and for farmers was just how important that life actually was. And yet
Yes.
we kind of neglected it in devising our modern industrialized system of agriculture, which has
Right. That
compromised that essential piece of how the soil works.
exactly. And we're headed for that directly to ask you about that. But you in this book is, I think, the best description I have ever seen of that life death cycle. It's almost like quantum mechanics. It's both at the same time, and this is absolutely critical. And restoring soil depends upon that too, bringing back this very unique cycle. The other thing that's so important that you've pointed out in your book is you just aren't going to have civilization unless you have soil. So we are so increasingly urbanized today, and we don't realize how much the planet depends for its health on soil. So thank you for doing that. Well, then another wonderful thing that you describe is the tilling, the plow, the invention of the plow. You go further and talk about the plow all the way back in history. But what's so big about the plow? And then we'll ask about modern farming. But the plow itself, why does that do damage?
Yeah, when we think about the plow, I mean, it's one of those agricultural icons that, you think about what do farmers do? It's like, well, they plow, listen to country radio, and that's what farmers do. They plow. Um, and so and it used to be on the seal of the U.S. Department of Agriculture, Thomas Jefferson's plow. Um,
Yes, you said.
and so, but it's kind of unusual to think of the plow as a destructive implement. But it actually has been one of the most destructive of mankind's inventions. And why is that? Because it disturbs the soil and it breaks up the fungal hyphal networks, the networks of the root-like structures of fungi that actually partnered with plants to get nutrients out of the soil and into the plants. Um, but and so the plow disturbs soil life in essence, and it accelerates the breakdown of soil organic matter, the remains of once living organisms that are a essential nutrient store and a way station in the cycling of nutrients from mineral particles into life and the recycling of life. And as you mentioned, that cycle of life and death that happens in the soil, you can think of the soil and the life in it as nature's recyclers. Because if nothing on Earth ever died, we'd be buried under living things, and if nothing that died ever rotted, we'd be buried under the remains of dead organisms. Soil is where the transformation of those once living things back into the raw materials that new living things can take up actually occurs. So viewed at a planetary scale, it's a pretty critical function of maintaining the viability and fertility and productivity of ecosystems. And that applies to a farm every bit as much as over the long run, every bit as much as it applies to a forest or a grassland. And so what we saw with the history of agriculture is that degradation process from tillage, from plowing, occurs slowly enough that you only notice it as a farmer, that the degradation effects over the course of a lifetime. So you'll notice back through history, there's commentaries from elderly farmers about what's happened to their land, but you don't
Yes.
notice it year to year. soil erosion is insidious, the actual loss of the soil, but it happens globally at a pace off of farmlands at about a millimeter a year. I mean, your fingernails grow faster than that. It's hard to actually watch and to calibrate. But I can't tell you how many farmers in their 70s and 80s I've talked to who, looking back at what's happened to their land over the course of the 20th and the first part of the 21st century, basically say, I don't have the soil my grandparents were farming. It's the same
Yes.
farm, but I don't have
Yeah.
the same soil. And what changed? Farming practices.
Yes, you interestingly point out also this goes back in civilization. So, where you had in ancient Mesopotamia very rich lands at one time for farming and stuff, that's completely gone now. It's a mess in many areas. But you pointed out there are these like cycles that the soil will last for so long. People didn't know as much as they know today. And it seems the knowledge is kind of recent, even to really understand what happens. But so it's a real problem. It's gone way back. But today we have a particular, shall I say, menace, which is the agrobiz approach, industrial farming. And so you have the plow, but so much more with it. Could you please tell us what the problem is with industrial or big farms today, big ag?
Well, the problem isn't so much large farms as much as it is how we farm on large
How you
farms.
farm. Right, I got
I've
it.
actually visited some very large regenerative farms that are mechanized, so technically they're industrialized, but they don't follow the same philosophy that really basically underpinned what we could call modern conventional industrialized agriculture. And so what are the basic elements of an agriculture that could actually build the health of the soil rather than degrade the health of the soil? And if we flip that around and first ask, well, what are the elements that degrade the health of the soil? The plow is at the top of the list, and you can go back through history and look at what the Romans did to their heartland, what the ancient Greeks did to their heartland, Mesopotamia, other societies around the world. And that's how I got into looking at and studying this problem, because as a geologist, you go back 10,000 years, and that's not much geologic time, but it's the fun time. It's the time that people have been around. So it was, I wrote a book, 15 years ago or so called Dirt that looked at that basic problem of the degradation of soil in ancient societies. And the plow was the villain of that book, because over the long run, the reliance on the plow over the long run degrades the life and the organic matter in soils that actually are the key to maintaining the fertility of soils naturally. So one of the things that actually led to the development of modern, what we could call modern conventional agriculture, was that by the late 19th century, the soils of Western Europe and great parts of North America, particularly the southeastern seaboard, once an agricultural breadbasket of the American colonies, they'd been pretty thoroughly degraded by centuries of tillage at that point, a couple centuries of tillage, sort of following on what the Greeks and the Romans had done. And the discovery that if you add a bunch of nitrogen fertilizer, you can boost crop yields even on degraded land, opened the door for modern industrialized agrochemistry. My lights are ecologically friendly here. They'll go off.
Don't worry.
If I sit still, I get dark. So basically, the rise of modern agrochemical intensive agriculture was a response to soil degradation from centuries of tillage. And it worked really well to maintain higher harvests. But once we then went to mechanized monocultures and started to specialize in growing either crops or livestock and segregating animal husbandry from crop production, it really opened the door for a trilogy of intensive tillage, fertilizer use, and pesticide use that characterizes modern industrialized agrochemical agriculture. Those three things right there are a recipe for altering soil life. And so if we look at, as I did in Growing a Revolution, if we look at farms around the world that have reversed the process of degradation and actually built healthy, fertile soils as a consequence of intensive agriculture, growing as much food, but doing it very differently, what are the common elements? Well, it's not plowing. It's growing a diversity of crops and in a rotation.
Right.
and keeping the ground covered at all times, growing cover
Right.
crops in between crops. Don't leaving the ground bare and naked so that wind or rain can erode it. Those,
Exactly.
those three principles, ditch the plow, cover up, and grow diversity, are a recipe for cultivating beneficial life in the soil.
Right.
Um, so that's really what I mean when I say that, agriculture missed out on the importance of soil biology, is that
Yeah.
practices that benefit soil organisms benefit the farmer as well. But they take a little time to pay off, and it's very counter to the advice that we've been giving farmers for the last 100 years
Right. And
in conventional agriculture.
right. I want to go into that in more detail in just a few minutes. I'd just like to get a good background now on big ag, especially with all the stuff it introduced, the fertilizers and the obviously the large scale tilling and all of that. I want to ask you about the chemical part of that too, because the nitrogen spill off from modern agriculture has done huge damage to the environment and so on. So these aspects of modern agriculture, any skill, the tillage and the fertilizers and the toxins. Can you tell us a little bit about that? It's such a part, especially of industrial agriculture. They really sell that stuff.
Yeah, I mean, when you
Yeah.
when you undermine the natural cycling of that soil biology can bring to the table, you need to replace it with something. And what we've done in modern conventional agriculture is replace it with nitrogen fertilizers and pesticides. And so when you do large scale mechanized monocultures on degraded land, and most of the world's farmland has been degraded by centuries of tillage and then conventional
Yeah.
agriculture, you're basically attempting to compensate for degraded soil. Now, what is it about nitrogen fertilizers that actually, contribute to
Yes.
that degradation? They basically accelerate the breakdown of soil organic matter. So the more nitrogen you add to fields, the more you degrade the soil's natural ability to provide the same service. And roughly, a little known fact about the fertilizer industry is that roughly half the nitrogen that we apply to farms as fertilizer never gets into a plant. It basically
Yes.
runs off, and that's what's causing the problem in the Gulf in terms of the
Yes.
nitrogen pollution that deprives the oxygen from the Gulf and creates a big problem there. It's
Yes.
what creates nitrate pollution, and it's why the city of, what was it, Des Moines, that sued the neighboring farm
Yes.
counties
Yes.
over the nitrate pollution
Yes.
in the city's water supply.
Right.
One of the big problems with nitrogen fertilizers is kind of counterintuitive. The problem is they're soluble. And you want, if you're going to try and get nitrogen into a plant, and nitrogen's critical for growing plants,
Yeah.
right? It's an
Right.
essential element. It can limit productivity. So there's a logic to why you might use it. But there's a downside. And that downside is that under natural cycling of nitrogen, that's what that soil organic matter is really good for. It basically has nitrogen in it because it was once living organisms. And the life in the soil can gradually mine that out and drip filter it into crops as they grow. And there's all these symbioses, these partnerships that have evolved in the soil between soil life and plants, and crops are no exception, that regulate, in essence, the timing of how that nitrogen is broken down and delivered to crops, that helps to synchronize what's happening in the soil with the growth of plants, because it's the growth of the plants that are providing the biomass that creates the organic matter that feeds the soil life. So there's this mutually beneficial set of partnerships that are in the soil that are every bit as complex and adaptive as what we see above ground between, say, plants and flowers and pollinators, or flowering plants and
Yeah.
pollinators.
Right. Right.
Um, those same kind of partnerships down in the soil help do things like cycle nitrogen. And when we apply a whole lot of nitrogen fertilizers to our fields, we can get the nitrogen into crops to grow big yields, but we're compromising the soil life. And that does other things in breaking down the soil organic matter. Gets farmers hooked on the nitrogen because we've cut off the natural supply, but it can also undermine the defensive system of crops, because a lot of the compounds that plants make to defend against pests and pathogens are called phytochemicals. They're compounds that plants make in response to insects nibbling on them or pest stress. And if we basically give plants a sort of free all-you-can-eat buffet of the main elements they need to grow, they let their shields down, to use Star Trek analogies. They basically relax their defensive posture, which makes them more vulnerable to pests, which means we need more pesticides. So
Right.
the sort of cycle that we get into, or we got into, in terms of trying to boost productivity on degraded soils with purely chemical means, basically undermines the biology that long made the system productive in the first place. And
Yes.
that's what I learned in Growing Revolution, is that there's farming methods that combine the ancient wisdom of things like crop rotations and diversity of crops and cover crops with the modern technology that allow us to do no-till and wean ourselves off of most of the fertilizer and agrochemicals.
Right.
And it's a whole different philosophy and way of looking at the soil that could underpin a new kind of farming.
Right. I want to come to that. Yeah, I want to come to that in just a minute. But before we leave this, the industrial style, what I mean by that, what they have introduced in terms of two more things here: monocrops and also GMOs that are really designed, genetically modified plants that are really designed to handle excessive amounts of pesticide like glyphosate, and that has had huge damage as well. So you've established that we've made sort of drug addicts of the soil, in that it wants a lot more nitrogen, but the nitrogen runs off. But what about the factor of monocrops and also this business of genetically modified plants that are tolerant of huge amounts of glyphosate?
Yeah, well, when we in the Green Revolution, when agronomists bred crops to be very responsive to high applications of nitrogen fertilizer, we were able to greatly increase crop yields. But part of that was because we bred for adaptation to high nitrogen inputs in a chemical sense. We could have bred for crops that were well adapted to high yields under high organic matter systems, but most of our farmland was already degraded at that point. So we would have not only had to breed crops differently, we would have had to restore our farmland. That's what the challenge I think we face now, that we're coming to realize that, at least I believe, was a missed opportunity 50 years ago, but
Yes.
it's a critical opportunity today because we know more about it.
Yeah.
And one of the problems with monocultures that it undercuts some of the fungal and bacterial partnerships that a diversity of crops produces. If you look at the below ground relationships, say in a native prairie in the American Midwest, all those interacting relationships between soil life and the prairie plants really led to a very productive high turnover system that supported tremendous biomass and biomass production, because the buffalo came by and ate it all every year. It needed to basically reproduce itself very well.
The locusts love it.
Yeah, and one of the big problems that sort of also has come more recently, on the heels of the going to essentially nitrogen fueled monocultures, was the need for pesticides, greater uses of pesticides. And if we look at rates of pesticide application through the 20th century, they went through the roof after we went to chemically fertilized nitrogen fertilized monocultures, in part because we undermine the defensive systems of our plants. And we talk about that in The Hidden Half of Nature and a bit in
Yeah, right.
as well. And then you get to your other question about essentially GMO crops. And in particular, in my mind, the biggest problem is not so much the GMO nature of many of those crops, but it's that they were designed to basically be resistant to large amounts of
exactly, which has been
herbicides.
swept under the table, right?
Yeah, and so what do we know about that? That's something that Ann and I have been looking into. My wife Ann Baclay, a co-author on The Hidden Half of Nature, and I have been looking at on the new book that we are almost done with, is looking at what does glyphosate do to soil life? And there's lots of sort of contradictory things you can find in the literature in terms of whether it impacts the bacteria abundance. Say there's not a lot of evidence it changes the total number of bacteria in the soil. Soils are full of bacteria,
Right.
but it changes the community composition. It changes who's there. It changes what they do, and it basically undermines many of the beneficial organisms in the soil, and it helps to facilitate the success of the pests and pathogens. Now, it's very good at controlling weeds because it kills any plant that doesn't have the patented gene in it. So it's kind of like the easy button for weed control. But there's other ways to do weed control and
Yes.
not till. And that's what a
And
big piece of Growing a Revolution is about.
right. And I want to go to that now. That's this is so well done in this book. And you give examples of comparisons, ways in which farmers have compared or researchers have been able to compare the amount of the same amount of nitrogen, but dealt to the plants in a different way, and so on. This is really brilliant. So we should go to that now. Then there's an emerging shift toward soil conservation. And so would you please describe that? What now people are very concerned about this wide scale destruction of the soil, and we have to have the soil in order to have life on the planet. So how does this attitude toward soil conservation, how has that emerged? What's that involved?
Yeah, when you look at that, basically soil is the foundation for agricultural productivity. It really is the foundation for civilization. And
Yes.
and I'm not claiming a new revelation about that. Thomas Jefferson wrote about it. The Greek philosopher Plato wrote about it. I mean, the idea that we need to protect the fertility of our soils is an old idea. And there were lots of traditional measures in societies around the world involving like cover crops and crop rotations and manuring fields, integrating animal husbandry and cropping. What's really new today is our ability to combine that kind of ancient wisdom with modern technology that allows us to disturb the soil less.
Yes.
And to get off of some of our other modern technologies like intensive fertilizer use and intensive nitrogen and intensive herbicide use.
Yes.
So I see a real opportunity for a hybrid of ancient wisdom and modern science in terms of reshaping how we think about the soil. And what's really new, I think, in the last few years, last decade or so, is that people are starting to think and talk about the health of the soil.
Yes.
And that's like a sea change in how we think about the soil. So it's not just a collection of, of chemical elements and we're looking at the chemistry and the physics of how to grow plants. We're getting back to the biology and thinking about, when we talk about health, we're talking about biological systems and complex biological systems, like the human body, for example. We're comfortable talking about and understanding our own health, but we're just coming to think about how to think about the health of the soil.
Yes.
And that involves the state of the organisms, who's there, how they all function together, how the system works as a collection of interdependent pieces. And when we think about farming that actually prioritizes building the health of the soil, we come to a completely different set of practices than when we think about it in terms of maximizing production on degraded soils, the way that modern agrochemical agriculture has specialized in and been very successful at over the last century.
Yeah.
So I'm arguing that we need a different philosophy of thinking about the soil and to prioritize thinking about soil health. And that would lead us to sets of practices like the farmers I interviewed in Growing a Revolution adopted. And I think that their success speaks, volumes to the potential for that to revolutionize agriculture. These farmers were doing better economically by restoring the fertility of their land, and they were growing, the quality of their land was improving, and the quality of the food they produce, we have now done some tests on, was improving. And then the amount of carbon that they stored in their soil was growing.
That's a whole point I want to take up. Right. Yes, you brought that out so well. Before I want to go into what exactly they're doing, to change this, that make this transition. But before I do that, I just want to compliment you on bringing out the voices of the farmers themselves, because we're used in our age, in this era, we listen to experts all the time, right? But if you only listen to some academic stuff, or in this field, very often it's quite penetrated by big ag too. The influence of the agriculture, the farmer, the productions. Companies, big companies, but the voices of the farmers and their knowledge of the soil, their recognition of the issue is very, very moving in many respects in this book, because they're able to look back a generation or two. And it's really valuable to have those voices. So thank you for that. Okay, then what exactly do you do? So you're a farmer, you've got this mess of dirt, basically, and you want to regenerate it. What's involved? Because you talk about a number of things that are extremely important here.
Yeah, well, at the simplest level, what's involved is cultivating the beneficial life in the soil. And it gets
Yes.
more complicated when you think about, well, okay, so how do you do that?
Yeah.
Um, and
But I mean that you get rid of the plow, right? But you brought up some other systems, some other processes that are very important,
yeah,
right?
when you think of, and I find it helpful to think about, sort of what would you do to support a community of any living organisms? Well,
Yeah.
you give them somewhere to live where they can live a relatively undisturbed life. And for soil life, that means stop plowing. Because when you run a plow through the soil, it's like a tornado visiting your house. It's not helpful for those inside.
Yes.
Um, and so they need shelter, and they need food. So when you think about soil life, what do they eat? Organic matter. They eat dead plants.
Yes.
So you need to basically have a good supply of organic matter in the soil, and that means growing crops that are not, pieces of which are not just exported. So you need some residue from your crops,
Uh-huh.
as it is called, or crop stubble, or cover crops that you just basically mow down and let rot, and they help get elements out of the soil, mineral particles, get them into organic molecules, and then when they rot, soil life does the job of teeing it up for the crop to then take up as fertilizer. And not just the major elements, but the minor elements too, things like copper and zinc and iron that crops need and that our bodies need. But they
Yeah.
get compromised when we take out the soil life that actually helps cycle those nutrients. And then the other thing that they need are partners. And that's where, foregoing monocultures and going back to a more diversified agriculture. Now, we could have an agriculture where you're growing kind of one crop at a time in a field, but if you keep doing that over and over and over, what you're doing is you're setting the table for pests. Because
Uh-huh.
if you've got, say you're growing corn in Iowa, and you're going to grow corn in the same field next year, you harvest your corn and a few corn weevils got into it, and they lay their eggs. And what do they really want to have there next year? Corn, because that's what they eat. If you diversify a rotation so that same field didn't have corn for another 3 or 4 years and had other things in between, the weevil problems would go away because they wouldn't have anything to eat. So there's ways to think about that. So you want food, shelter, and partners in a community. If you look at one of the reasons also to grow diversified crops is the same reason that when we live in villages or towns or cities together, we each have different jobs.
Mhm.
Because together, if we're each specialized in doing different things, we can get more done. um, and the soil is similar. Different life forms provide different kind of services, partner with different plants, and if you have a diverse team of life in the soil, they can actually it's a more resilient and functional system can have better resilience in the face of things like droughts or disturbance.
Yes.
So if you think about it that way, what we need to do is stop plowing, grow cover crops, and grow a diversity of crops rather than functional monocultures. And that's the exact opposite of what we've been teaching people to do for 100 years in agriculture.
Exactly. Yeah. And you bring out so well for example, well, one of the first panic things would be, well, we're going to have all these pests, we'll have all these bugs, or we'll have all these bacteria that are negative for the crops and so on. And you do a beautiful job, if I may say so, of pointing out, well, if you do this right, the rotation, the ground cover, the no plow, obviously, it will take care of itself. The pests will go away or be greatly minimized because you are balancing this soil nature. And really, that is great.
Yeah, and that helps. And the other thing that happens is that the predators come back. The insect predators that eat those
Yeah.
pests come back, because one of the little recognized or talked about realities of broad spectrum pesticides are that they don't just kill the pests. They also kill the things that eat the pests. And if you go
Yes.
back to your ecology textbook and look at the examples of like deer and wolves, what happens when you kill all the wolves off? The deer explode.
Yes.
Later the wolves come back and eat more of the deer, right? The predators will follow the prey. And so when you
Yes.
think about an agricultural field as an ecosystem, if you kill off not only the pests, but also the things that eat the pests, well, what's going to come back first? It's not the predators. It's going to be the pests. And so when you regularly douse fields with chemical pesticides, what you're doing is you're basically ensuring you'll have to keep doing that because you're taking out the things that could naturally solve the problem for you. The downside, of course, is that you're never going to completely eliminate pests with a natural solution. You're going to have to live with some of them. But living with a few of them is different than having them decimate your fields. And what we've
Exactly.
done is we've through modern agriculture, we've made our agriculture more vulnerable to pests, which means we're more dependent on pesticides. There's a different
Yeah,
way to do it, though.
yeah, yeah, and gotten rid of all the predators that would have balanced the system out. And it's not just in agriculture, but it's a huge problem. You really explained that just so well. Okay, so here are the ways to do it. People are doing it. Evidently, they're seeing the success of it, but we still have big ag. So I want to ask why that system continues, that you have a little background, maybe if you could, about the control of farmers through these huge agricultural corporations and the subsidized agriculture and also the debt. Does that figure into maybe the slow progress in this direction?
Well, I mean, it's a long, complicated story as to how sort of modern agriculture ended up where we are today from the start of a lot of farm related legislation in the Dust Bowl era. I mean, the Dust Bowl era really kind of triggered great awareness about the vulnerability of farms and the need to support farmers. And a lot of very well-intentioned legislation got put forward that had sort of unanticipated consequences over the long run
Yeah,
in terms of trying to encourage farmers to segregate crop production from animal husbandry. And it turns out that you can do regenerative farming without livestock,
yeah,
but you can accelerate soil building with the proper integration of livestock into cropping systems. It just needs to be done right.
yeah,
And so, once we started to basically divorce animal husbandry and cropping, we took away a key tool that farmers were able to use to actually maintain the fertility of their land. That was done under the philosophy of the idea that specialization will allow efficiencies and larger scale production at lower cost. And we've got really good at producing a whole lot of cheap food. But one quick question, whether it's the right kind of food,
yeah,
grown in the right kind of ways. And
right.
that's a subject that Ann and I tackle in our new book, which will probably be called "What Your Food Ate," that looks at sort of the question of the way how we farm influences what gets into our food and what it then does for us.
Great.
But there were a whole series of policies that essentially facilitated the growing size of farms and put a squeeze on family farms. And, as a geologist, I like to sort of step back and look at it in the big picture. And how I look at it is that in the 20th century, we did sort of two things farmers got caught between two things. They got increasingly told that they needed to go to larger farms because they were producing large amounts of just a couple crops. It's one of the things that monocultures facilitates is large scale commoditization of crops because you grow a lot of things like corn and soybeans.
Yeah,
Um, and so what happens when you, as for two farmers, when they grow a whole lot of just a couple things, they get paid less for doing it because
yeah,
they're producing a huge surplus of just a couple things. And that's in essence a characteristic of a commodity market. And then what happened in terms of how they were doing it? They were basically increasingly told and taught that they needed to do it with the assistance of expensive chemical inputs, whether it was
yes.
petroleum, nitrogen fertilizers, patented seeds, or agrochemicals. If you look back at the history of what's happened to the cost of those things, they've gone up in real dollars. What's happened to what farmers get paid for their harvests? They've gone down in real dollars.
Right.
So
And the
farmers,
debt is huge, isn't it?
bingo. And what's that a recipe for? Farm debt. Uh,
Yes.
and so we basically reshaped agriculture in the 20th century with good intentions, but that with results that produced unanticipated outcomes that have squeezed small family farms and encouraged farmers to either get big or get out, in the famous words of I think it was Earl Butz back in the 70s.
Yeah.
Uh, uh, so farmers have been kind of caught in the middle, and the farmers that learned a lot from in terms of visiting for writing Growing a Revolution were farmers who had run into economic issues with that model decades ago and started the transition to a more regenerative agriculture, usually out of economic necessity because they lacked the money to buy the fertilizers, for example, that they needed under conventional practices. And they found that as they brought their soil back to life, they didn't need as many of the things that they were told that they needed to buy lots of. So some of the farmers I highlighted in Growing Revolution have essentially weaned themselves off of chemical fertilizers and and pesticides, agrochemicals, including glyphosate. And they've done it by restoring fertility to their land, by restoring life to their land, using those three principles of ditch the plow, cover up, and grow diversity that we talked about earlier. And over time, that's allowed them to basically have a better economic model on their farms. And that's why I've come from being something of a pessimist and looking at the history of ancient societies and how we're on track to destroy our soil globally today with conventional practices if you let it play out another 100 years or two, or maybe less. But I've become much more of an optimist after visiting these farmers who have demonstrated that there's a different way to do it and that they won't go broke doing so.
Right. And they're actually, the production is better, apparently. But Dr. Montgomery, we're going to run out of time here shortly, but there are a couple of things I want to ask you about before we end. And I could keep this up all day. There's so much good stuff in that book. But you pointed out the debt issue and the difficulties for farmers, but it's interesting. Their approach is much more scientific, actually, today, isn't it? And they are achieving great success. I think that we will hear a lot of complaints from the companies, the big companies behind this, that, oh my gosh, we've got to feed the whole planet. We can't possibly do it unless we do big ag. But you have pointed out, no, that is not true. First, there's the issue of how much food we waste. And secondly, that this regenerative done right is more productive.
Yeah, I mean, the general go-to argument you hear from people in defense of large-scale industrialized agriculture today is that without it, we would starve. And
Yes.
yet, when you really poke into that and look at that, what that argument is generally based on is a 10 to 20% yield penalty between organic and conventional agriculture in studies that, for the most part, were trying to grow crops on degraded land organically. Which doesn't work very well. You get a big boost from conventional practices on degraded land, but it begs the question of, well, what if you restored the land, and how long does that take? And what really impressed me was how fast land can be restored. It can take decades to ruin a field with a plow, but it can, or centuries even. But I've found examples where farmers within the course of a decade or two, sometimes even within less than a decade, radically improved soil organic matter and productivity that within just a couple years of adopting the kinds of practices I was talking about, one can get yields back up to comparable to conventional. And in terms of profitability, that can be managed within a year or two. The transition period is real, but it's short. And I think a real challenge for policymakers globally is how to look at the public interest, the human interest in preserving cropland for the future and restoring it should motivate us to help farmers make the transition. The ones I interviewed did it on their own, and they did it successfully economically. But they all said that basically, if there had been policies and revised subsidies that encouraged regenerative practices, they would have adopted things faster, and more of their peers and colleagues would adopt things faster as well. And yet we still subsidize conventional practices that degrade the land. We have our subsidies on backwards.
Yes, yeah, you make a very good point of that. That's something we don't hear a lot about through the media, but we know something, say, about subsidized farming, but not this downside and how it keeps farmers on a leash, basically, and keeps them in debt and the whole thing. But thank you for pointing that out. Before we go, and I said there's so much to cover here, but before we go, you brought out in one chapter the business of sequestration of carbon, which is a very big issue today, and some brilliant examples of how to do that. Could you explain why the role of the soil in grabbing the carbon and what happens if you use big ag and what they're doing to revive that good practice?
Sure. I mean, my eyes were open to the potential for soils to rapidly assimilate carbon through how my wife gardened our yard.
Oh, yes, that book.
Yeah. So in The Hidden Half of Nature, we talk about how she took our yard from about 1% carbon up to almost 10% over the course of a decade through gardening practices
Yes.
that are essentially the mirror image for the home environment of what we've been talking about on farms. And
Yes.
so in Growing Revolution, I visited farmers who had taken their soil from 1 or 2% organic matter up to 5 or 6% in some cases over the course of 10 years, sometimes a little more. But that's a huge and rapid change. And they also deepened the soil horizons that had
Yes.
lots of carbon in them. So they were able to basically start using the soil as a carbon sink to take carbon out of the atmosphere. And photosynthesis is the best method ever invented for doing that.
Thank
It's
you.
been around
Yes.
and time tested for 400 million years. It works, and it basically can take carbon out of the atmosphere, and that organic matter that gets into the soil is roughly half carbon. Not all that carbon stays in the soil when that organic matter decays. Roughly half of that will go back into the atmosphere from respiration from soil organisms, but the balance of it can be built up over time.
Yes.
And how high can it be built up? That depends on what practices you're using, what climate
Yes.
you're in, what kind of soil you
Yeah.
have. The answer is different for every farm. But if you integrate that globally, the answer is, well, an awful lot. And
Yeah.
there's a lot of academic argument about how much carbon could be put in the world's farmland soils and kept there for how long. And I kind of view that argument as missing the point. The point is that we can put whatever that number is, we can do it while improving the fertility of our land, improving the profitability of our farms, decreasing our dependence on agrochemicals, and growing healthier food for more people. I see it as sort of a net benefit and a net positive. And what we should be arguing about is what's the best way to put the most
Best.
carbon back in soil as fast as possible. And
Yes.
there's plenty of room to argue about that. And there's lots of room to argue about, well, how long will it last there? Is it a short-term sequestration, a short-term storage that we shouldn't use the term sequestration for, or will it stay there for 10,000 years? There's lots of arguments to be had over the specific forms of carbon in the soil and how that works. But from my perch, what I've basically become convinced of is that it's one of the biggest, essentially, infrastructure projects we need to tackle globally, on par with or maybe just after the climate issue. And they're coupled because
They're coupled.
every bit of carbon we can take out of the sky and put in a farm field below our feet is a net plus.
Yes. Yes, and I like to tell viewers that you give some examples where people compare different methods and of the sequestration, also several methods of a number of things, but this is really terrific information. There's just the approach of carefully studying this and having different ideas that against the blitz right now that we're going to have this high tech carbon sequestration. Some of these methods are very, I want to say weird. I can't think of a better word at the moment, but
that's a fine word.
Trouble for that. But they don't scale. There's a lot of expense and difficulty with them. This is natural. This restores the soil, and I hope that people will get hold of that in this book. It is really important. And before we leave, you also mentioned this other wonderful book that you wrote with your wife about the restoration of soil in your own yard, and that is magnificent. So I hope people will look at both of these things. Is there anything else that you would like to add before we have to end?
I think I'll just pick up on your last point there and basically mention that, we as people, we tend to be fairly fascinated with technological solutions. We're a really clever species. but we're not always very wise. And
Yes.
what we need to realize is that we have a potential solution or a partial solution to many problems right beneath our feet if we would just treat our soil differently.
Exactly. You just see this possible transition to understanding that if you could go back to natural processes, nature has been at this for a while and does a very good job. So we could do a great deal here in this book, though. It is wonderful, and it's cheering to see that people are doing these experiments and succeeding very, very well, that it is possible to get a handle on this terrible situation that we've found ourselves with. Dr. Montgomery, thank you ever so much for joining us today. It was very interesting to talk with you. I want to do it again. And I hope that people will take a look at this book. That needs to be a movie. It really is very fine reading, as all of your books are. And I wish you the very best with doing this wonderful human service. Thank you.
Yvonne, thank you very much. As always, it's a pleasure to talk to you.
Thank you.